Okay guys, so this is 1038. It's asking for the distance x to the centroid. So that's basically the distance this way. So given is this line right here. This is supposed to be at 100, but the image drew it like this in the book, so ideally this is supposed to go like this way, and this shouldn't be here, but it's not what the book did. So yeah, so yeah, this is the end of that. Okay, and so we're gonna start with just the x distances. This is 1, this is 2, and this is 3. Okay, so first off, 1, so you get a total of 200, divide that by 2, right, because it's a square, so you divide those by 2, and you get 100. So that's this individual x distance, right, regardless of any axis. That's what it is. You know, if I was taking it out here, the midline of that would still be, you know, because it's 200 in length, it'd still be 100. So this part is 2. So you have 30 goes to 15, right, because half of 30 is 15, and we're coming from this way. Number 3, so 100, right, put it anywhere, and you divide this by 2, so 100 divided by 2 is just 50. Okay, so that's that whole row individually. The next one is pretty simple. It's the area, right, so just 200 times 30, right, because it's the height of 1. So 200 times 30, you get 6,000. 140 times 30, you get 4,200. 100, right, times 30, you get 3,000. So then you just add them all up. That's your sum. The next one is just multiplying this number by the area. Okay, so that's just that number. This is 63,000. This one is 150,000, which makes sense. And so then you sum them all up, right? But you do these individually first, right? You don't do it all at once, right? You don't take all of these numbers and all of these numbers and add them and then compute that area. You take them individually and then you sum them. So then that's how you get this, which I believe is the distance to the centroid, which is the first part of the problem. Okay, so now that that's out of the way, the next part is this, which is probably the hardest part about this. So this is going to basically be your base times height cubed divided by 3 or divided by 12, but in this case all of this is being divided by 12 because the middle axis is right here, right? And so there's no really, any of the shapes are not on the axis, right? Because I'm taking all their bases right here along the, you know, it's good to take the axis along either the y or the x, you know, not the shifted axes. And you got to remember that there's a centroid axis, shifted axis. Centroid is per shape, okay? The shifted axis is the whole thing that's given that's not on the regular axis. So you want to take it about the regular axis. Well, that's what I do. It makes it easier. So the reason why this is 0 is because this is the bottom one, and as you can see, basically the midline of this, right, is 100, right? And 100 is where the axis that's shifted should be, right? You know, I know that this picture is all messed up, but 30 plus 70 is 100, and the half of the bottom is 100. So you don't have to worry about that one. The next one is this middle shape, right? And so I'm looking at it from this way, okay? And so you're looking at it like this, right? You're not taking these two because this 30 and this 30 are part of the top and the bottom pieces. So we're just looking at the middle piece. So you're gonna do 30 cubed, right, times the base times 1, oh shoot. Times 140. Okay, so you get that number. And then you divide it by 12 because this obviously is not on this axis right here that it gives you. Right, and that's one of our theorems, is that when it's not on the main axis, you don't divide it by 3, you divide it by 12. If it was along this axis that we were looking at, you divide it by 3, but we're looking at this shifted one. So you get that number, okay? So then you have to add that to a number squared, which is, so you know how this is 15, right? And this line that we're looking at, which is this x, right? This is at 100. So 100 minus 15 is 85, right? So you could type in 100 minus 15, right? 100 minus 15 squared. But I'm gonna just put in 85 because I don't like doing the parentheses. So 85 squared. And you're gonna multiply this times the area, which is 4,200 for this shape. 4,200. Okay, so 3.066 times 10 to the 7th. All right, the next piece is this top piece, right? So coming from this bottom, right? So we have 100, which is our height, right, in this case, even though in reality it's the base, right, because we're looking at it from this way, okay? But because I said I'm using the 1/3 or the base height cubed all the time, I'm just looking at it the way it's like coming at it, right, from the x. So right, it's 100 to this line, so that's our height. 100 to the 3rd times, what's our width? This base is 30. Okay, so you get that number, which is a big number, and you divide that by 12. So now, where are we? Okay, the half of this is 50, right? It's 50, so 50 to 100 is just 50, right? Because 100 minus 50 is 50. So 50 squared times, what's the area? Is 3,000 times 3,000. And those are our numbers, right? That's what's written right here and here, okay? And so you just sum those. You get 4.066 times 10 to the 7th. All right. So now, I mean, we're coming back to the, you know, the original centroid, right? The x distance to the centroid that I asked in the beginning, which is 61.6. So what you're gonna do is you're gonna take the magnitudal distance, right? Not the positive or negative. The only time this will be negative, the only time this row or distance will be negative is if the object is being subtracted from the picture, right? But we're adding all of these, okay? And it's not necessarily negative, but you're gonna basically, it won't, okay, this is just always positive, no matter what, whether, you know, see how 100 is more than this and 50 is less than this, it's always gonna be positive. It's just the magnitude distance. So you get 100 minus 61.6, 38.4, okay? 61.6 minus 15, 46.6, right? 61.6 minus 50, right? Because it doesn't matter, plus or minus 11.6. Okay, so now what you want to do is you want to multiply these by the areas, the individual areas. Okay, that's how you get these numbers. So just for example, 38.4 times 6,000 to 3,400. The rest are equal to these numbers, right? And it's just this times this, or this times this, this times this, this times this. And so you sum those, okay? And basically, that's your whole object's area of motion, or of moment, when you add them together, okay? So that's the answer in the book, right? You get these two answers from the book, okay? And so that's 38, 1038.